Have you ever wondered how deep tech companies actually start? Well, we were too.
So in this podcast, we'll be interviewing scientists and entrepreneurs that have taken their ideas out of the lab and turned them into startups. I'm Antonia.
And I'm Christina, and this is Startup the Science.
This podcast is brought to you by INAM Berlin, the Innovation Network for Advanced Materials, bringing together the brightest minds in material science. Visit us at inam.berlin. Space. What do we know about space?
All I can hear in the back of my mind is like the do 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 do.
We should really have more sounds in this podcast.
Yes, we should.
Okay, so you might be wondering what is going on. So today we are going to talk to a startup from Australia,
NextAero,
who are building nothing less than rocket engines, which is pretty cool.
Very cool.
So what they are trying to do, and they'll tell us more about it, or Graham will tell us more about it. He's the CEO and founder of NextAero. They are working on sending satellites to space at a much, much lower cost. So to prepare for this podcast, we were thinking about space and space exploration.
Woohoo! Do 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 do.
All right, and then we also add some sound effects. But why this is such a fascinating topic and why everyone is interested in it. I mean, last year, because we met NextAero when they came to our accelerator program to AdmaCom. And I remember when we were going through the applications and theirs popped up. They were exciting, first of all, because they were from Australia and that was far, far away. But also because they were the only ones doing anything with space and everyone got excited about them. And that's kind of interesting that all humans seem to get excited about space.
Why is that, Antonia?
Why is that? Maybe because we're very curious and we want to know what else is out there. And we assume that there's probably a lot we don't know about, because there is. And a way to find out what's going on is to send things into space. That's like a child's explanation of space exploration.
Wait, so Elon Musk, I think his idea is that the world is going to end. And so the only way...
Ideas. He also thinks we're living in a video game.
This is true. He is a very interesting dude. But yeah, he thinks that the only way that our species can survive is if we go out and explore the other...
And find another planet to live on.
Yeah, exactly. So...
That makes sense.
That's another reason.
So that's a good reason. I think today we'll focus more on more realistic, practical, short-term reasons, like seeing the Earth from far, far away and what benefits that could bring us. But I think that's maybe not why space is as exciting. Maybe finding life on other planets is a more exciting reason to explore space.
Aliens.
That's we don't even feel that this is worth a sentence. It's just aliens.
I think I've just watched way too many space movies, and so...
And recently everyone is wearing these T-shirts with the NASA logo.
Yeah, that's really trending at the moment.
Really trending at the moment. And in the beginning, I thought everyone, I don't know, started working there, but turns out, no, H&M just made T-shirts. Right, that was then a tangent there. Anyways... So we'll call Graham and we'll talk on a more serious note about space and what NextAero does and why Graham got into space exploration in the first place. Hi, Graham. How are you? Welcome to our podcast.
Hi, thanks. Thanks for having me.
It's great to have you and great to talk to you again. So I guess we've already kind of mentioned what field you work in and what you do, but it would be great to start off with more of a proper introduction. So can we talk a bit about space for a while? Can you tell us why you're passionate about the whole field of space exploration?
Yeah, I think space is at a particularly interesting time at the moment. During the 1960s, I think there was it was quite a bit of a novelty just to make it into space, and it was kind of just the feat of it that was impressive. But I think recently, during the 2000s, we've really entered this new phase, which is all about how we can actually commercialize space. And there are lots of new applications for small satellites, for larger satellites, for rockets, for reusing rockets that are happening at the moment. And we're having a bit of a golden wave that's pretty exciting, and a lot of startups are getting involved in that. And so, yeah, I'd say there's a bit of a space boom on at the moment, and that's what we're interested in.
So that is all very, very exciting. And I think, there are many things that are interesting about it. One thing that I think is very cool is how much cheaper it is now to send satellites into space. And maybe we can talk a bit about that, because I think the general perception is still that it's a very expensive thing to do. It used to cost billions, then millions, and now it's possible to do it with a couple $1,000s even. So can you tell us a bit more about that?
Yeah, it certainly has. The price to get to space has dramatically decreased, I think by about 10 times since the 1990s even. And so that's really happening with a lot of commercial enterprises that are particularly coming out of the United States, but also Europe and China as well. I think the development of space at the moment is really heading the same way that the aviation industry has. So in the early 1900s, when flight was first invented, essentially it was only used for the first 40 to 50 years, really as sort of a military and experimental tool. And that's because it was just too expensive, because the tools and ways of making aircraft and certifying things were just too expensive. But then during the 1950s with aircraft, we really figured out how to commercialize them on a larger scale, and strengthen the supply chain for their development. And I think a similar thing is happening in space at the moment. We're really working out these are the standards that we should use for how rockets should be built, for how satellites should be built, and that's all helping to bring the cost to access space down.
That's exciting. And I think for us, for non-scientists or people not working in this space, when we hear of satellites or NASA sending another satellite into space, I think the main thing that we obviously think about is space exploration, maybe finding life on different planets, things like that. You talk about the commercialization of space in a way, right? So what are the other applications that maybe are more down to earth, I don't know, more applicable to our life here on Earth, rather than finding other planets or finding things we don't know are out there?
Yeah, so the interesting thing about space is that it's just so big. So when you hear things about NASA exploring Mars or the moon, that's tremendously far away. What I guess space commercialization is looking at right now is really the very low Earth orbits and some of the geostationary orbits. So these are the ones that are really close to the Earth. So I guess to give you kind of a perspective on that, say you're in Australia and Australia is the Earth. Right now, the commercialization is looking at boats just off the shore, about that sort of distance. But what NASA is doing on Mars and the moon, that's sort of like all the way to New Zealand. So that's really far away, right? That's almost 2,000 kilometers. So the commercialization is really close to the Earth. What we can do from those kind of distances is actually provide and augment services that are happening on the Earth. So there are a lot of applications with mining, with agriculture, with water management, land management, with tracking the surface of the Earth over time that small satellites can provide, and that's a lot where the commercial development is currently happening.
Right, and that is the space in which NextAero, your company, operates in, right?
Yeah, we're doing something kind of similar to that. We're helping to put those small satellites into orbit.
And so we talked about how the cost of that has decreased a lot. Can you tell us a bit why that's happened? Without knowing much about it, you can imagine, I could imagine that it should still be very expensive, right? The materials should be very special materials to be able to get into space and stay there for a while. Why are the costs sinking so much?
So there's a lot of reasons why they are coming down. Partly it is the use of more advanced materials, so 3D printing, lightweight carbon composites, ceramic matrix composites are really reducing the weight and increasing the strength and increasing the reliability of different components. The miniaturization of electronics is particularly useful for small satellites, and to put a satellite into space, basically you're just paying for the mass, so you pay literally per kilogram. So the costs at the moment are sort of around maybe 20 to 30,000 US dollars per kilogram for a satellite. So if you can actually put some of the sensors on a Raspberry Pi or even smaller sized board and put these in a really small satellite, you can actually just reduce the mass that you need to put into space. And so that's having a very large effect. But in addition, the increase in technology around materials and material performance is also really boosting that.
That's amazing. And we talked in our previous episode about the importance of advanced materials and how they're changing a lot of they're changing the world around us as we know it. And it's interesting to see they're also changing this side of the world or of the space. That's cool. So let's talk a little bit more about some of the potential applications. Who are the main clients, let's say, for small satellites?
Yeah, so there's a few different ones. I guess you have to break it up in a few different segments. So those people that are interested in looking at what's happening on the Earth's surface. So that would be those examples that I gave you before. So say a mining company is interested to measure the size of their mine or measure the composition of the soil or anything like that. They would be interested in a type of imaging satellite, and that can be done in a small form factor, like on a small satellite, maybe sort of 100 kilos in mass. Say you're a farmer and you're interested to know where your plants are stressed by disease or pests or lack of water. You can actually look at the whole spectrum of light that's being emitted from those plants across your entire farm and actually see that there are small spots where there is stressed plants. And so now you can have sort of a targeted approach and reduce the amount of pesticides and reduce the amount of water use across your farm. There are other applications as well. So remote asset management, so basically being able to track how maybe a tractor is traveling in a remote farm, or if a water tank is full or empty in rural Australia, you can actually put a little sensor on that tank, and when the small satellite flies overhead, you can beam up that sensor information. That did exist before, but what's happened now is that because we can have so many of these smaller satellites, we can use a large network to get more timely information back to the cloud. So now you can read what's happening with that tractor, on a half hour or even 15-minute type basis rather than every few days. So there's some of the applications that are happening, mostly in the spatial and then, sort of the Internet of Things.
So we're getting to the point where it's cheaper. It can be very useful. So does this mean, for instance, if we take agriculture as an example, does it mean in the future, the next, let's say 30 years, every farmer will be able to just easily launch his satellite into the orbit so he can see his crops, a bird's eye view of his crops?
Yeah, you can actually already do that. So there are basically it won't be that the farmer that will launch the satellite. The farmer will use a service and basically just log into a website, kind of like Google Maps, and instantly you get not only the picture right now, but actually you can access what your history has been over the last 5 years or so. You can look at how your farm has done, and you can also do kind of real-time tracking of that. But I think the satellite networks will really be moving towards a service type economy. So it'll be like you pay for a subscription service, and now you can see the quality of your farms.
So this might be a stupid question, but as I asked if every farmer can launch a satellite, and then obviously that's not the case, I'm wondering, is there a reason why, how can I ask this in a slightly less dumb way? Is there a reason why we would launch a lot of small satellites as opposed to launching a few bigger ones that could monitor larger surfaces? Does that make sense? So how many small satellites can we have in the orbit at one point in time without overcrowding it?
Yeah, so you can have a lot. So we're talking 10 or 20,000, if not more, of these small satellites. So they're only about 100 kilograms. So maybe the really decent, like industrial ones, they're about the size of a washing machine, and the smaller, more experimental ones, they're about the size of a shoebox. So we can actually put many thousands of these in orbit. You may have seen some images online of how densely crowded the orbits are around the Earth. The Earth is very large, and so I think it's just sort of an artifact of trying to represent the Earth and a satellite in a single image that gives you the false impression that it's completely chock full. What's also improving is the ability to track where those orbits are. And so that's another big thing that's being worked on. If you can put your small satellites all offset in the orbit slightly, then you can get completely global coverage on a really short time scale, so that the satellite flies overhead every 15 minutes or so, and you can get complete pictures of the Earth every 15 minutes, or complete device scans of the Earth every 15 minutes, and that's what I think the future will look like.
Okay, another stupid question. It might not be stupid. I think I read this somewhere that the satellites fall out of orbit and it could possibly kill humans.
This is true. This
it
has
is,
happened.
right?
Actually, in Australia, recently enough, some part of a satellite fell. Is that not true?
Yeah, sometimes they fall. Yeah. So majority of the pieces will burn up on re-entry because the satellite is traveling so fast that the air basically is like sandpaper against it. It just heats up and will burn the spacecraft. But then some pieces catch enough drag that they slow down so quickly that then they just fall through the air like something tossed out of a plane. That can happen. They put them in special orbits to make sure that the chance of that happening is very, very low. Yeah, and they're also able to track them to find out where that might happen if any debris does fall. And they can use small little thrusters on board the satellites to kind of adjust that so that it happens over the open oceans.
Which leads us to our next question, because we actually did a lot of research for this podcast. You'll be impressed to know.
I know a lot about space now.
We know more about satellites than we did before. But I also read that one of the plans is to make, especially small satellites, sort of self-destructible, that at the end of their mission, they would not come back to Earth, but they would, I don't know what they would do. They would self-destruct in some way. Would they burn down? What would happen?
Yeah, they would. They would use their small little thrusters to push them down towards the atmosphere, so that they go into an orbit where they really just graze the upper layers of the atmosphere, and then they'll experience the most heating, and they'll just disintegrate.
Oh, that's kind of sad. I mean, especially if you get emotionally attached to them before they take off. But hopefully that's not the case. All right. So thank you so much for these explanations. Now, it would be great to know what you guys are working on.
How does NextAero fit into all of this?
Yeah, so we're helping to put those small satellites into space. So there are a lot of companies right now, I think, trying to basically build more efficient rockets. I kind of see it as we're in, sort of the 1920s of the space world, where everyone's building all these crazy contraptions because no one really knows how to get to space super efficiently. So you can see SpaceX building reusable rockets, and then Blue Origin trying a different type of rocket, a couple of different ones in Europe as well. NextAero is trying to just build the rocket engine that helps these guys get into space really efficiently. So we're working on a type of rocket engine called an aerospike. And this engine has been known for a little while, but no one really knows how to make it work. And we've done some tests, and we think we can make it work. So I guess our value call card is that we can increase the number of satellites that you can put into space by about 30%. So increase the mass to space by 30%. That's pretty significant for a rocket.
That is very, very impressive. And we're pretending not to know, but we do know because you guys obviously joined us in Berlin last year for our accelerator program for Admocom. So we were quite familiar with your technology. We also saw on your website that you're working on a new project. So you had Project X, and now you have Project Next. Is that right?
Yeah, that's right. Yep.
Do you want to tell us more about each of them? What was Project X, or what is Project X, and what is Project Next?
Yeah, so Project X, that was our first attempt to basically build this special type of engine. So I guess it probably works to start with what an aerospike is. So it essentially takes that traditional bell kind of shaped engine that looks like a cone at the bottom of a rocket. It takes that cone and flips it inside out. If you do that and you have the cone inside out, it allows the vacuum of space to expand the rocket flame that comes out way more efficiently than any other method using that normal cone. The problem with turning that cone inside out is that now you've got everything covered in really hot flame gases, and so melting the engine becomes like a major issue. Project X was an attempt by our lab here in Australia. I work in a fluids laboratory at a university called Monash University. And we put together a project to see if we could overcome the cooling and melting challenges using metal 3D printing. So basically, we brought our knowledge of how fluid mechanics works and how to keep structures cool, and we brought it together with metal 3D printing, which can make really, really, really complex geometries and cooling pipes going in all directions buried inside the surface. And we tried to see if we could basically make it work and make the aero spike not melt, and we succeeded. So that was sort of the genesis for our company, because we knew that if we could overcome these challenges, and that would be interesting, that would be very useful for the industry at large. And so now Project Next is our commercialization version of that engine.
That's very, very exciting.
So
and
cool.
We were very excited last year when you applied,
Yeah.
since you were the only startup that had anything to do with space. And I think everyone finds that exciting for different reasons. Very different reasons. So I think it was also interesting to see in the 10 startups that we had last year, you probably had very different challenges than the rest of them. Because when it comes to who your potential clients might be, who your potential industrial partners might be, it's a very different field, and maybe more limited in a way, because the bigger players in this space are quite a few and quite strong, quite powerful companies, right? So how does it work for startups in this space? Pun intended.
Yeah, it's definitely challenging. It's not impossible, I think. You just need to set the scope of what you want to do. So I think at the moment, space companies are really kind of going all out. They're doing a completely integrated venture. So SpaceX, for example, Elon Musk basically bankrolled that to start with about $100 million. And then from there, they've done many capital raisings to basically build the entire company. And the company does, from start to finish, the engines, the vehicle, the launching, etc. There are other companies around the world that don't do that and are doing more of a typical supply chain. So they're integrating different components and trying to maybe offer a service, or they offer just a hardware product, or maybe they offer the different tiers, I guess, of services and products that you can offer. And so we're targeting more of that side. So we find companies that are trying to do different types of satellite launches, and companies that are open to using different products, or purchasing technology from another company that's been de-risked. So that's more of the route that we go down, to find these companies that are more open-minded and doing less of the whole value stack, we call it.
Right. And is Elon Musk the hero of every startup in this field or not? It's a random question.
He's definitely my hero. I know that he's taken a bit of a battering in the media recently. So I do wonder. He's certainly my hero, that's for sure.
Nice. All right. I'd love to talk now a little bit about your background, just to try to understand, how does one get into the business of space? Because I'd imagine a lot of boys growing up think about becoming astronauts or working somehow in something to do with space, but a very small percentage of us actually get there. So how did that happen?
I have always been interested, I guess, in aviation generally. Australia didn't have a space agency, so I didn't really, until very recently. So I didn't really grow up as a small kid wanting to be an astronaut, but I was interested in being a pilot because I thought flying around looked amazing. I did that for a little while. I got my pilot's license, but then I found that I wanted something that was a little bit more creative. So then I went and studied aerospace engineering, and that was really exciting, and I got a complete thrill out of that. And then I wanted to, I guess I was maybe a bit more interested in more of the science behind what was happening. And so then I was interested in doing a PhD. And I think along the way, I've been exposed to aviation and science so much that I got a sense of what was possible and what the industry looks like in Australia, Europe, and the United States. And when we got an opportunity to build a rocket engine, who turns that down?
That is very impressive. Maybe this is a good time to tell people how young you are as well.
I'm 27.
That's crazy that you're a pilot and an aerospace engineer and have built a rocket engine by the age of 27.
You're like the perfect astronaut candidate.
Maybe Australia have some astronauts, I'm not sure.
you could still be an astronaut, Graham.
Would you though, if you could and you were given the opportunity?
Of course, yes, absolutely. I would go to Mars, definitely.
Mars.
But maybe you can build your own rocket engine just for that and
Just do it
go
yourself.
on your own.
DIY Mars expedition.
So we talked about what NextAero is doing now. We talked about your background. It would be great to know what the future looks like. What is going to happen after Project Next? What's next after Next?
Yeah, so essentially Project Next, as I said, it will be our attempt to make sort of an industrial scale engine. After that, we're really looking to partner with some of these companies to help integrate the technology into their launch vehicle, their rocket. So I guess you can already get the sense that this industry, the space launch industry, is really similar to the aviation industry. So in the aviation industry, you have engine manufacturers like GE or Rolls-Royce who make the big jet engines that hang off a Boeing 737, and then an airline, purchase that Boeing 737 like Qantas or Ryanair or someone like that. And then you have maybe even someone further downstream like Expedia who actually manages the tickets. So the space launch industry is on its way to start to look like that at the moment. And so, yeah, we're hoping that NextAero can be an engine manufacturer, a pretty prominent one in the future.
Interesting. So what would be the equivalent of Expedia in a satellite world?
That one already exists, actually. You can go and send whatever you want into space and buy a ride right now.
Oh, and how is that? Is that legal, though, to send whatever you want into space? What are the limitations?
SpaceX sent up that car, right? So
That's
I
true,
guess
they
you
did.
can.
Yeah, it is legal. You need to make sure that you don't damage other people's property, so you need some pretty intensive third-party liability insurance. There are some major restrictions around radio communications, so you can't just go into space and turn your Wi-Fi on, for example. You need a very special license that says you're going to use these frequencies at these powers, etc. But outside of that, you can really put what you want into space as long as you play by the rules.
Crazy.
Right. And what would people or not people, I guess it's not a lot of people sending things into space, but what would companies most often send into space?
So they would send, universities are really into sending these shoebox-sized satellites called CubeSats, and they send those up and they try to demonstrate, typically, new technologies that are being developed inside the universities at the time. So some of those are on high-efficiency solar panels, some of those are really efficient communications, some of those are using lasers, some of those are imaging things on the ground and trying new techniques at resolving small features maybe. That's what universities would send, and then companies are at the moment sending up prototypes to try and tap into this new commercial market. So a couple examples there are a company in Australia called Fleet. They've sent up some small satellites that have really powerful antennas on them that can receive these little signals by tractors and things like that, and then report on different properties of the tractor, maybe the tractor's fuel consumption or where it is on the ground or something like that. So they've sent up some small satellites with really powerful antennas. So they're two examples, I guess.
Cool. Thank you so much for joining us today and for educating us in all matters space related.
And before we say goodbye, is there a website or email you'd like to plug?
Yeah, sure. You can go to our website, which is nextaero.com.au. Yeah, or look me up on LinkedIn, Graham Bell on LinkedIn, which you can find if you're interested. Yeah, happy to hear an email from you.
Cool. Yeah, and I'll leave those links in the description.
Thank you so much. We hope to see you soon, maybe in Berlin again, if you come by. And we'll definitely talk to you soon.
Great. Thanks very much.
Thanks.
Have a great day. Bye.
You too. All right. See you later.
Thanks for listening to Start Up the Science.
If you like our show and want to know more about what we do, check out our website at inam.berlin.
And don't forget to leave us a review. Until next time.
Bye. You can get the bye.
I think I like it.